We are going to find the exact value in radians for each of these problems. The first one says the tangent inverse of 1. I'm actually going to rewrite this a little larger. We're going to do the tangent inverse of 1. And if you remember that that's actually going to give us the angle. Of course, it says angle in radians, so we'll find it in radians, not degrees. But technically, this is actually 1 over 1 as a fraction. Because the tangent inverse is the opposite of the regular tangent. I say opposite, it's the inverse of it. I switch the x and y. Normally, it's the tangent of the angle would equal the ratio, the 1 over 1. In fact, this 1, or 1 over 1, is really just the opposite. That's the top, and this is the adjacent. I don't know why I did that as a y. That should be a j. Adjacent. There we go. Now, that just tells me something about like the triangle, the picture of this. I got some triangle, and I have some mystery angle, and we're trying to figure out that angle. But I do know that the opposite is 1, and the adjacent is 1. We're supposed to find the exact value because we should know exactly this triangle. This triangle looks familiar. This is a 1, 1 square root 2 triangle. So we should actually know what that angle is. This is just a good old famous 45, 45, 90 triangle. It's isosceles. This is a 45-degree angle. Of course, wait a minute, we're supposed to do this in radians, so our angle is actually pi over 4, if you remember your radians. Now that's my answer, but you also might think, wait a minute, hold on a second. I know stuff about the inverse. Normally, there's actually many, many answers that this could be. We actually found the 45 degrees, or pi over 4. That's actually quadrant 1. All students take calculus. Technically, there's another spot in one full rotation. There's another triangle over here, another positive 1, another 1 over 1, that would give us an angle. So there's another angle over here that actually is also an answer. However, you might even think, well, wait a minute, can't we actually go all the way around and then stop again? More than one full rotation? In fact, can't we go around 5 times and then stop here, or even stop, he was adjusting my circles, or even I can go around a bunch and then stop here. In other words, what kind of answer do we want? Since it only says just find the exact value in radians, that makes me feel like it only wants one answer. It only wants the first one, the most basic one, quadrant 1 for our answer. We're not worried about quadrant 3. We're not worried about infinite loops around. We're not worried about the infinite possible answers. We just want pi over 4. So our answer is pi over 4. I put theta there. Really, I could say tangent inverse of 1 is pi over 4. And that's our answer. Okay? And let's move on to this next one. So this next problem says we want the cosine inverse of 0.5. Now, as I rewrite this again, I'm actually going to make it be not a decimal. I'm going to put it as a fraction. And we like it as a fraction because even here, I put the value of 1 as a fraction because that was our ratio of opposite over adjacent. Now, for this cosine problem, again, we're finding the angle, but the regular cosine is actually adjacent over hypotenuse. So this 1 must be our adjacent, and the 2 must be our hypotenuse. So I'll draw that triangle down here. Here's our angle we're looking for. And of course, we know the adjacent, that's a 1. We know the hypotenuse, that's a 2. Again, since we're doing this to find the exact value, we should exactly know this triangle. We should recognize it. This is a 1, 2 square root 3. And of course, we should know this angle. This angle is actually a good old 60-degree angle. But we're supposed to do this in radians, so we should know what 60 degrees in radians is, or just convert it if you got to. But it's just pi over 3. And that's our answer. And again, for the same reason, we're actually not worried about the other infinite possible answers for our cosine inverse. We only want the principal value, the main one. We actually want the quadrant 1 answer for a most basic triangle, because all of them are positive here for a most basic triangle. All of them would give you the most basic things of an opposite or adjacent or a hypotenuse that are positive. Now, technically, all students take calculus. There's more answers that would solve this cosine problem. There's more angles. Pi over 3 is one of them. But we could also go down to the fourth quadrant. We could either go a negative angle, like negative pi over 3. We also could go almost all the way around here. What would that be? 5 pi over 3? But we don't want those ones. In fact, we could even loop around a bunch of times and stop at any one of these positions, but we don't want it. We technically only want the most basic answer here. And I can tell because of how basic the question is. It just says find the exact value in radians. Boom, I found a value. The answer is pi over 3. This thing has an answer of pi over 3. That is my answer in radians. If it wanted all infinite answers, it would say find all values that would solve that in radians. Or if it wanted just quadrant 1 and quadrant 4, it would have said find all the answers within one rotation. But since this problem didn't say that, I can safely assume it just wants the first answer. So we got the first answer for each of these. We're done.